In this video, we're going to talk about the present value of an annuity. So in our previous video, we discussed annuities, and we said an annuity is a type of investment where you're making a regular payment, where you're putting the same amount of money into an account, or you're paying off an account with the same amount of money every month, as opposed to a basic compound interest question or a simple interest question where you're putting money into an account once and then just letting it sit. So yesterday, well, in the previous lesson, we did questions where we were trying to figure out the final amount, and today we're going to take a look at present value, or trying to figure out what the starting amount was. So our question here says, Quentin buys a $2,000 sofa and finances it at 5% per annum compounded annually for 5 years. If his annual payment is $461.95, complete the table below to model how he pays off the sofa. So, important things: the sofa is $2,000, it's 5%, it's being compounded one time a year, we're doing it for 5 years, and his payment is going to be $461.95. So we're going to use the table to model how the annuity works, and then we'll talk about a formula. So in year 0, Quentin walked into the store and he signed away his life to buy a sofa for $2,000. He didn't have the money all at once to pay for it, so he financed it instead. So in the first year, they charge him interest on the $2,000. They actually charge him 5% interest. So to figure out 5% interest of this, we take $2,000 and we times it by 5 divided by 100. Just going to zoom in a little here. Or you times it by 0.05. And we get that he gets charged $100 in interest. So that means that he owes $2,000 on the sofa, plus he now actually owes $100 more in interest. But he makes a payment. He makes a payment of $461.95. So we take the $2,000 that he owed for the sofa, we add on the $100 in interest, and we subtract out his payment of $461.95. So 2,000 plus 100 minus $461.95 means that he now owes $1,638.05. So year 2 rolls around and he has to pay interest on what he still owes. So he doesn't owe $2,000 anymore. He now owes $1,638.05. So he gets charged 5% of that. Yes, you can see it. So $1,638.05 times 0.05 means that he gets charged $81.90 in interest. So he still owes $1,638.05. To that, he's now being charged another $81.90 in interest based on what he has not finished paying off yet. And then he's going to make another payment of $461.95. So that gets deducted from our total. So every time his payment pays off a little bit of the balance and all of the interest. So 1,638.05, add on the interest of $81.90, and then take out the $461.95, and he owes $1,258. So slowly but surely, he's finding a way to pay this off. Okay, next year comes around, and he still has to pay interest on what he owes. So he owes an extra 5% of $1,258. So 1258 times 0.05 means he has to pay $62.90 in interest. Plus he makes his payment of $461.95. So he's got that remaining balance of $12.58. We're going to add to that the interest, the $62.90, and then subtract the $461.95, which is his payment. So $12.58 plus $62.90 minus $461.95. Means he now owes $858.95. Okay, we're going to calculate 5% of that, which is $42.95. So I didn't write the calculation down for that, but I did the same thing as I did with all the previous ones. He pays $461.95. And he takes the $858. He adds on the interest of $42.95 and then subtracts out the $461.95, and he now owes $439.95. Now it seems odd to me that we have one more year to go and what he owes is less than his last payment, but he's going to get charged interest one last time here. So we get interest charged on this, so 5% of this, which is $21 and actually $22, right? Because that 7's going to push that up. Okay, we are paying off $461.95. So $439.95 plus $22 is $461.95. If I take away that last $461.95, ta-da! He's free and clear. He's paid off the sofa. It's his to keep. So when we were talking about regular annuities, where we were trying to find final amount, we actually looked at the pattern and figured out a formula that would work. And we could do that, but it would take us a lot of time. So I think what will happen is I'll put it on the board for you to take a look at if you're interested, since the examples are going to take long enough to get through today. So I'm actually just going to tell you the formula, and then we'll prove it in class. I'll put it on the board for you so you can take a look at that if you're interested. So the formula for an annuity, it's a little bit different than the other one, because this one here, instead of adding every time, we were actually subtracting our payment, which makes it a little bit different. So the formula here is going to use the same letters as the previous one, except instead of doing the final amount, what we're interested in when we're doing these calculations is finding the starting amount. In our calculations that we've done for compound interest and for simple interest, when we were trying to find the starting amount, we use the letter P for the principal. And it's going to be P equals R, which is our regular payment, times 1 minus 1 plus I to the power of negative n divided by I. Okay, this is a crazy looking formula. It looks similar to the one that we did for annuities in the last video, but it's a little bit different. So here, the P is our principal, it's our starting amount. R is our regular payment. I is our interest rate as a decimal. We do that by dividing by 100. And N, and you have to notice it is negative N. It's easy to miss that negative. N is the number of payments, or the number of times you're earning interest. So we're going to do a couple of examples to look at how to use the formula, and then if you're interested in how this is derived, you can look in the textbook or you can ask me in class. Okay, I think we'll actually take a look at the example in the next video so that we don't run out of time.